Hello friends, welcome back to my channel Learn India 24 by 7. In the last video, we have discussed about statistical significance and we have covered the below topics. In this video, let's discuss and understand about one sample Z test. We will cover below topics. So let's begin. So friends, let's discuss about one sample Z test with example. Imagine you are working at a hospital and looking at birth weights of 30 newborn male babies. You would like to study and conclude that babies born at this hospital are heavier than national weight of newborn babies. The national average weight of male babies is 7.5 pounds with standard deviation of 1.25 pounds. With this data, we would like to determine with 95% confidence if male babies born at this hospital exceed the national average weight of male babies. We shall use below process steps to find the solution to this problem. First, we will determine if Z test is appropriate to use. Next, we'll find the Z statistics. Then we'll determine if we need one tail or two tail test. And then finally, we'll find the p-value from Z table and compare it with our significance label. In this case, we are given with the population standard deviation and sufficient number of sample data points. Hence, we can use Z test. The equation for Z statistic is x bar minus mu 0 divided by sigma divided by root n, where x bar is sample mean, mu 0 is population mean, and sigma is population standard deviation, and finally n is sample size. The denominator of Z test statistic is sigma divided by root n. If you recollect the example of rolling dice, this is the equation we derived for standard deviation of mean. To avoid the fraction within fraction, let's pull square root of n from denominator to numerator. With this equation becomes like this. From this equation, it is very clear that larger the sample size, larger the Z value. From the given data, we have sample average as 7.833, population mean as 7.5 pound, population standard deviation as 1.25 pound, and n, which is sample size, as 30. With these values, Z statistic equation will look like this, and Z statistic value comes out to be 1.461. Determining one tail or two tail test to use is like asking if you just want to find out your sample mean is different than population mean, or you are interested in knowing which side of population mean is your sample mean. Here are few examples. So in this case, as we are asked to conclude if the average weight of newborn babies in the hospital is greater than national average, not just different, so we will use one tail Z test here. So to find the Z value in Z table, we will use one tail Z table from left. Since our Z statistic is 1.46, we will search for value 1.4 in rows and same way value 0.06 in column. From Z table, we can see a value of 0.9297. Subtracting the value of 0.9279 from 1 result in a one-tail p-value of 0.072. At 95% confidence, we need a p-value of 0.05 or less. So we can't say with 95% confidence that weight of newborn babies in the hospital is greater than national average of newborn babies. So friends, let's discuss now on what can change the current result. So how can we get 95% or higher confidence? Let's work on the problem backward. The equivalent Z value for 95% confidence level is 1.65, which we can find by looking at the value 0.95 in Z table. In order to be more confident that our hospital has higher weight babies than average, we either need to make our babies even heavier compared to the average or increase the number of samples. Out of these two options, the most viable option is to increase sample size or number of samples. If all other parameters remains as it is, and to get a Z value of 1.65, we can solve this equation to get a required N value. This results in an N value of 38.3. Rounding it off, this would require 39 samples. So if we measure 9 more babies and get the same average weight as we have now, then we could make this claim with 95% confidence that babies born in our hospital are heavier than national average. But it is obvious that by adding 9 more samples, the average weight could go up or down. If you want to run Z test in Excel, it is quite easy. You can do that by using below shown function. The function is z.test. Parameters are array, x and sigma value. Whereas array is our sample data set, in this case it is the weight of 30 newborn babies. X is a population mean, in this case it is 7.5 pound. And sigma is the population standard deviation, in this case it is 1.25 pound. Sigma shown in bracket indicate it is an optional value. If you don't include, Excel will use the sample standard deviation from the input data, that is sample data. So friends, with this we have come to end of this video. I have referred completely the book Hypothesis Testing by Scott Harrison to prepare this video. In the next video, we will discuss and understand about one sample t-test and pair t-test. So friends, if you have liked this video, do subscribe to my channel. And don't forget to like and share your comments for this video.